Okay, it's 1 minute past 12 in Europe. I should welcome you all to the second day of the joint GeoGFOI workshop on exploring new tools in CPAL to assess land use and land cover changes and produce greenhouse gas emission estimates. I'm the climate coordinator at the Geosecretariat, and I'd like to give you a quick overview of the agenda for today. So following yesterday's demonstration of two software packages in CPAL, BFAST and SITS, we will today resume the demonstration session with 4 more software packages. Continuous Change Detection and Classification, CCDC, by University of Boston, Global Forest Carbon Flux Model by WRI, Forest Canopy Disturbance Monitoring, Fcdm, by the Joint Research Center, and Sentinel Cloud-Free Annual Composites for REDD+ by the JRC as well. And after that, there will be about 50 minutes for a moderated discussion to get feedback from the audience, but also for reviewers to provide some initial reflections on the usability of the selected software in CPAL for greenhouse gas emission estimates in the land sector. And for demonstrators, sorry, there's an echo. Okay. And for demonstrators to discuss support and resource requirements. And finally, we would like to agree on the post-workshop process and timeline together. We'll try and wrap up a little bit earlier today, depending on how the discussion goes. Next slide, please. Before we start, just a reminder how to participate actively in the meeting. First of all, indicate your full name and affiliation so we know who you are when you interact with the panelists. And to do so, please post your questions in the Q&A box in between presentations. The speakers will try and respond in writing, and the moderator will pick up some questions for the short Q&A sessions following each demonstration, and then also for the longer discussion at the end. For the moderated discussion session, you may also raise your hand if you want to speak up. And finally, be aware that the meeting will be recorded and we will post it on the Geo website. So now I will turn to Gilberto Camara, Geosecretary Director, for an official welcome and a short summary of yesterday's session and the initial discussions, and then Tom Harvey, who will facilitate the meeting today. Thank you.
Hello, good day to everyone, and it's an enormous pleasure to have you back here, both panelists, presenters, expert groups, and representatives from the organizations which have been supporting this workshop, and of course your attendees. Very, very happy to have you. So just to sum up and remember, yesterday we had a very important and interesting setting the scene presentations. And we'd like to thank IPCC Task Force on Inventory, Sandro and Carly, for providing us with the background of what IPCC has tasked us to achieve. And I think we have to look at this as something very important, that we have an IPCC request for GFOI with the support of GEO. And then we had also very interesting presentations on 2 issues, which I think relevant to the community, very relevant. One is the effort. This is ongoing for Digital Earth Africa. I think it's a major positive development for whole continent, and which has enormous contributions both to forestry, agriculture, and of course to the humanity as a whole. And also on the status of biomass. And I think you've seen now from Laura that this new initiative, GeoTrees from Geo, is really pushing forward to have biomass information that can be used by national forest monitoring systems and countries in their global stock take and the reports they do in REDD+. I think this is a very positive development, because this helps a lot in terms of the normalization and standardization of the reports to be sent to UNFCCC and other groups. And then we had two interesting presentations, tools, and we'd like to thank Jan Besselt from Wageningen and Remy from FAO for showing it is operational on SIPO right now, the BFAST tool. And the Karine and Hope Simões from Impia, Brazil, showed the SITS tool, which was demonstrated to you. And today we're pleased enormously to have another group of very distinguished researchers who have provided us with their, invaluable contributions to the GFOI and SIPO. So this is going to be very important. So can I just share my screen? One issue here. So what I'm going to show you is, and this is, I always have this mess, but this is a researcher mess. So work program, GFOI, it's always this confusion. Okay, so we have the privilege of having a huge amount of quality experts here. So what are we going to be asking to the experts? So we have here the tools that were presented. They have made their calm assessment. And we're going to draw, I mean, like the Americans like to say, there is no free lunch, right? So if you're contributing, you're expected to help us. So the experts will individually help us by providing their calm assessment of the tools, by informing what they think are the strong points and the weak points, if any. And important here is, please inform us what is the potential of the tool to reach calm level 6 or above. And what is, and if any, recommendation you would have in that regard. Also, please tell us, in your opinion, what is the potential to contribute to the AFOLU requirements, which is different from the CALM requirement, because there's very specific points made yesterday by Kali and Sandro, and say, what is the potential to contribute to that? Another very important point, I think various people came up yesterday with that, was what does this mean in terms of the users? What are the capacity development requirements? And conversely, what are the suggestions you would make for tool developers? For example, you need to improve your capacity. You need to think about who's going to use and how do you progress in CALM. And finally, I think that's the easiest answer, is the tool, let's say, in your vision, ready to proceed to phase 2 that we'll discuss. And finally, Carly, it's very important, and I think this is an important development. Are you available, and what is the willingness that you have to provide training materials for Openmrv? Again, Openmrv is a very important development that includes a lot of important players, the World Bank, IPCC, GFOI, and therefore increasing your visibility of your tool in Openmrv helps everybody. So this is something that will be passed on for the experts, and they will provide feedback to the developers as we go along the next phase. So thank you very much. And I pass the floor back to Tom.
Excellent.
And by the way, this I think the expert group has received a link, a Dropbox link, where you have the materials that we're collecting for the workshop, and also the presentations that we're going to put there. So if you share the presentations, I'm going to put in the Dropbox link to make immediate access to the experts and papers and so on. So if you have additional material on your tool, send it to me. I'm going to put it on the Dropbox so the experts can see it. Thank you very much. Tom?
Excellent. Thank you, Gilberto and Sarah, for setting us up. It's lovely to be with you again. I hope you all didn't get too sick of hearing my voice yesterday, because you're going to hear a little bit more of me today. I do realize the Australian accent can be a little grating at times, so I apologize in advance for that. But we had, I think, about 150 people quite consistently turn up for yesterday's workshop, which was very impressive. I mean, and people stayed too. I think the measure of a good virtual workshop is whether people stay. It's very easy to duck out quietly from a virtual workshop, but people did hang around, and we're creeping back up towards the three-figure mark again today. So people clearly found it interesting enough to return for a second day, which is very pleasing. I noticed a few of the Australians on the call smile as I scoffed at the Australian accent there. Sorry, Carly and Adam, in advance for bringing our nation down. But let's get on with it. So we're going to dive straight back into the demonstrations, which is what we're here to see. And first up is a long-standing and much respected member of the GFOI community in Curtis Woodcock from Boston University, who's going to be demonstrating CCDC. Over to you, Curtis.
Okay, now, thank you for inviting me. Happy to be involved. Sorry it's not in person. Missed the opportunity to catch up with everybody that you usually get at meetings like this, but we'll have to do the best we can, I guess. So I can't follow instructions. I can't really do a demonstration on CPOL because I've never used CPOL, and Eric mentioned yesterday that CCDC is accessible from CPOL, and so maybe at some point we can get to the point where we can do a demonstration on CPOL, but I would like to show you how we have been using CCDC and a little bit about the tools that are involved, and then we can go from there. So I apologize for not following instructions. I've never been very good at following instructions, but anyway. Paulo Arevalo is online and available to help answer questions, which is good because he knows more about the implementation details than I do, and created a lot of the tools that we're using for doing this. So he's also offered to help answer questions online while I'm talking. So if you put questions in, you might get an answer from Paulo. But I'm going to focus really on kind of how we've used CCDC in the past, and that goes to the question of how ready is it to contribute to things like MRV and that sort of thing, and then the availability of tools. And as always, there's a sort of a cast of characters out there, many of which you'll see referenced in the context of various projects and that sort of thing. So, you know, CCDC has been around for a while. The original paper was published back in 2014. Part of Jeju's dissertation. I don't really have time to go into any details about the algorithm, but it's a time series model that's based on harmonic regression, uses all clear Landsat observations, all spectral bands, which is, of course, you can choose what you would like to use as the inputs. It really has two stages, one where it searches through the time series and looks for what we call breaks or changes, times when the time series no longer follows the patterns it has in the past. And so you're learning from past observations what to expect in the future. And then when that doesn't happen, we insert a break and then continue. And then at the end of the time, we classify the time between breaks or the segments between the breaks. And the possible results include, you know, land cover maps at any time during the time series and kind of continuous monitoring of change. And some of the things I consider sort of key ideas behind the whole thing is that we sort of assume observations are noisy, and so you have to see a change multiple consecutive times in order to be convinced that it really is a change. We use when it comes to classification, if you're using all the available images, you have to boil those down to some sort of set that can be used. We call those spectral temporal features, and they include things like, you know, the amplitudes of the spectral bands and those kinds of things. And our approach is a little different than most in that it's online. It starts at the beginning and runs through to the end sequentially. And so in theory, at least, it's easily updated. Not as easy as it sounds, but in theory it is. How we used it in the past, the first real application was in our own backyard, looking at loss of forest land, mostly to new housing and urban development. Maybe most immediately relevant for this group is Paulo's work in Colombia, in the Colombian Amazon, where as sort of a prototype MRV or for red reporting, he He used CCDC to produce land cover change estimates for the whole area, all the way through to area estimates that have been bias corrected and the uncertainty characterized. He put a lot of focus on what happened after deforestation, and he illustrated some of the difficulty that was shown up in many places now of estimating very small areas with high precisions. For example, if you're trying to estimate change for a single year, the areas are very small, and to get good margins of error in those estimates can be quite difficult. And so we've been working on solutions to those kinds of problems as we go forward. It's also been applied in other contexts. This is a huge area of the above study area, a big NASA program in Canada and Alaska, looking for land cover change, finding a variety of kinds of changes in vegetation, mostly climate driven at higher latitudes. Eric Bullock did a very nice study in Guatemala, looking for areas of disturbance and deforestation for that country, mostly in a conservation context, but the methodology is very similar and very relevant in this context. Just this quick note about trying to use these spectral temporal features as part of the classification process. It reminds me a little bit of the discussion yesterday about the SIT's work of trying to classify using much more information than the individual images. And so I thought that was worth noting. A quick note to point out that we've been through the process of translating these land cover changes into the effect on carbon fluxes. And we've done it in two ways. This one is an example of kind of a tier 3 spatially explicit approach that we've recently published. But we have also gone through the more population scale or approach 2 level in a number of environments as well, including including this part of Colombia, excuse me. And so for this approach, for the tier 3 approach, the actual carbon accounting is done at the pixel scale and uses the input from CCDC directly to estimate the fluxes at pixel scales. If you expand a little bit beyond land cover and land cover change to include degradation and disturbance, Eric did a very big study of the Amazon basin, and in essence mapped and then based on a reference sample estimated the areas of both deforestation and disturbance. And so you can see the area estimates there sort of on the right with the confidence intervals around them. And also translated that into estimates of carbon flux. And so there's sort of a carbon dimension to that project as well. More recently, and this is yet published, but it's been reviewed once and is in revision, is applying similar ideas for monitoring disturbance in a more temperate environment for the country of Georgia. And then I've been given some slides to show from the LCMAP initiative in the US, Jess Brown. LCMAP is an operational program within the United States to provide land cover change information. And so for this question of can this be used operationally, well, the US is using it operationally at this point in time for producing this sort of suite of products to estimate things like land cover change areas over time in the United States. Here's an example of one of the sort of specific products that they've been producing. And here's kind of the schedule they've been working off of. Last year, they produced their first sort of collection, they call it, 1.0 through 1985 through 2017. And collection 1.1 came out this April and it extended a couple of years. And you can see the other plans down there, they are trying to make the shift to cloud computing. Their implementation of CCDC was done on an internal system via a Python version, which is publicly available of CCDC, an open source version, but they're now trying to make the move to cloud computing as well, which is kind of interesting. At the moment, we are in the middle of a big project to try to do this globally. and so we've been trying to scale up the process to do this. We've been doing all the scaling on Google Earth Engine. And so we're in year 3 of a 5-year effort to try to, in essence, produce global results of land cover and land cover change based on CCDC. And here's kind of the goals for the whole thing. And we have kind of a wonderful set of international collaborators. I don't know, maybe I haven't looked carefully who's online. Maybe some of them are online. So that would be nice. From different places around the world. So what about using it and other people using it? Paulo wrote a nice paper recently that documents many of the tools, not around running CCDC so much, but around using the results. And CCDC produces kind of a lot of results. And so I'll show you stuff on time series viewers and spatial data viewers. There's also documentation for the actual classification tools, and then for area estimation and map accuracy assessment. And so this is kind of a published set of documentation. There's also online documentation, and these are just screenshots. I was nervous about doing sort of an online demo of these things. So I went through and took screenshots of a number of them so that you can see what they generally look like. And then if you walk down through this, you get the results for the individual things, CCDC results visualization, creating charts of time series and interacting with them. This is what the instructions sort of page looks like. This is what it looks like when you do it. And so for some of these, I'll show examples of in Google Earth Engine, this is, for example, what the time series viewer shows you. You can click on any pixel and get a time series in any spectral band or index that you want. And you can fit a CCDC model to it on the fly. So you can see what the results are likely to look like. You can also click on any of the individual dots on these plots, which are the individual Landsat images, and get the Landsat image themselves. Oh, and you can, so this plot is a conventional time series plot, which is done sequentially by year, but you can also do these day of the year plots, which help you illustrate the seasonal patterns or the phenology associated with the individual pixels. And so if you look at a place like this small little black dot, I don't know if you can see that online very well, but you can also click on any individual point. And you can see down here, if you clicked on this point, you would get this Landsat image, which was before the change that occurred in this particular place. And if you click on an image, oops, afterwards you get, oh, I got the wrong image. Sorry, no after image for this one. And then here's back to the instructions web pages. We're visualizing the coefficients for the harmonic regression models and the change information. One of the things that we use this for, and it can be quite helpful for us, to generate what we call synthetic images, which are basically our version of a predicted image at any time in the time series. And so you can pick a date and then create kind of a seamless image for the area that you might be interested in. And here's kind of the wet season, and here's the dry season. And so you can kind of use these as an easy way to visualize Landsat data over large areas in a seamless way. And then there are a variety of ways to look at the results of CCDC in terms of the detection of changes. One is you can plot the time of what we call the maximum magnitude of change. The magnitude is measured as sort of the difference between before and after a break in the model. You can also look, well, that's the maximum magnitude, and this is the actual magnitude. The other one was the time of the maximum magnitude. And you can also look at the number of breaks. Some places have multiple breaks and changes through time, and some have none. And a big step in this whole process is making land cover maps. That's where the land cover change information comes from. And so there are classification tools for doing this that are available. You know, it's fairly conventional in the sense that it requires training data and all the steps that you would be involved. There's the land cover tutorial. Eric Bullock pulled this together and involves all the steps that are involved in trying to get to the land cover and land cover change information. And there's an example in here from Uganda. So my summary here, I tried to get through this relatively quickly, is, you know, we've used this for applications around the globe for land cover change, and continue actively engaged in that process. CCDC results have been used all the way through to carbon fluxes, both at sort of the population scale and spatially explicitly. It's used operationally in the US by the USGS. We're currently in the process of trying to apply it globally. And we've been pursuing new variants, mostly focused on this issue of forest degradation. There are currently sort of two functioning versions of CCDC. One, you know, we're research and development people, not software engineers. So there's one on Google Earth Engine that was implemented by Google, no Gorlick at all. And apparently that is accessible from Sepal, at least that's the impression Eric has said. And there's also an open source Python version that was developed and maintained by the USGS that's publicly available, which is what they're using for LCMAP. The supporting tools for use of CCDC results are important. It's a little more complicated than I think most systems might be, and so there's documentation in multiple forms. There's the paper that describes this stuff, as well as the documentation online for Google Earth Engine. So I'm hopeful that there'll be a way to get to using CCDC easily and effectively within Sepal. We're not really the people to do that, in the sense that we're not really software engineers, and we're more research and development people, but we're very happy to be supportive and are very, obviously very supportive, and have worked for many years in the domain of trying to help countries get to the point where they can do effective RED reporting, as well as general monitoring of changes within their countries. So with that, I guess I better stop and leave it for questions.
Excellent. Thank you very much, Curtis, for that lovely overview of CCDC that's clearly being applied at a number of different scales. I remind participants to please post your questions in the Q&A box, and we'll ask Curtis to do his best to respond to those in writing during the next session. If anyone has any burning ones now from the panel, or you're able to quickly type it into the Q&A box now, please do. I just had two very quick ones for you, Curtis, as well. The LC map initiative in the US, what's that monitoring? Is there a particular policy or program that's monitoring? And my second question was the global results where you're applying CCDC globally. Are you involving countries or national governments in that work as well, or is it something that's being purely led out of Boston Uni as a global exercise? So they're my first two for you, and we'll see what comes up in the Q&A.
LCMAP is a general initiative to monitor land change. LCMAP is land change monitoring, assessment, and projection. It's the U.S. government's attempt to understand how the land surface is changing in the U.S. It's not in support of any specific policy per se, other than sort of the general requirement to monitor and understand change in the U.S. The global initiative is in fact global and is being done at BU. We have this network of international collaborators that are helping us. Some of them are from governments, most of them are not. Most of them are regional land cover change experts that we've, many of them through old connections from GOFC Gold and other places, Silva Carbon, that sort of thing. And so they're helping us with our work in these different parts of the world, but we're not engaging each individual government as part of our effort to try to produce these results. That would be kind of outside the scope of what we can do and be a bit overwhelming.
Yeah, a much bigger exercise, I can imagine. Thanks, Curtis. There are a couple of questions popping through, coming through for you in the Q&A. We are a little short on time, so I will pass over to David Gibbs shortly for the next one. But Eric, I just wanted to throw to you quickly. I noticed you popped something in the chat briefly. Just wanted you to maybe give a quick summary about CCDC in CEPL from your perspective as well.
Sure, thanks, Tom. I can give the 2-minute summary. Thank you, Curtis. I typed it in text. I'll say it in words. Thank you, Curtis, to you and your lab for doing the research and development on CCDC. It's a wonderful tool that I think we should, make sure it gets in the hands of as many people as possible to carry out their work. And that's what we're trying to do with also through the CEPL platform. So I just want to say quickly that you can get on to the CEPL platform, create CCDC assets for any place on the planet. The assets are created, saved, and then you can query those assets in terms of what Curtis talked about, like creating a synthetic image for any point in time, using the CCDC coefficients in your classifications for change detection and all sorts of other things. So the idea would be to use the paper that Arvelo wrote about the applications of CCDC in conjunction with some of the tools available in CEPL as well. And you can include it in your other workflows.
Excellent. Thank you, Eric. That's a very useful clarification. So a reminder to participants, any more questions for Curtis, please do pop them in the Q&A box and he'll respond to those as we go. And I suspect there will also be some more questions for you in the discussion later on, Curtis. So thank you once again. I think it's about 6:30 in the morning where you are. So anything that doesn't have a 7 in it, as far as I'm concerned, in the morning is an inhumane hour. So you've done very well to present it at that hour. Thanks for being so flexible. But we'll move on to our next demonstration now, which is by David Gibbs from WRI, who's going to be presenting the global forest carbon flux model. Over to you, David.
Great. Can you hear me?
Yes, very well.
Great. Hello, everyone. I'm David Gibbs. I'm a geospatial researcher at the World Resources Institute. I'm presenting on behalf of myself, Nancy Harris at WRI, and collaborators from many different institutions on a flexible framework for global maps of 21st century forest carbon fluxes. So this is a little bit a change of gears from other presentations we've seen so far about looking at land cover changes. Is about actually mapping forest carbon fluxes themselves. I know I'm not in presentation mode. I'm going to be switching from slides to CEPL, hopefully doing a live demonstration and then back to slides. And so being in presentation mode for the two switches was going to be potentially too confusing during the demonstration. So I'm just going to use this, and I was told that this is sufficiently large for people to see. So hopefully that's the case. Right, so maybe this is just going to show up, but that's okay. There's nothing up there. Right. So the general framing for this, all of you would be familiar with this, I'm sure, all the panelists, but we don't really know, we don't have a great sense of where greenhouse gas fluxes are coming from in forest, either the emissions or the removals. And obviously, it's important that we know where fluxes are occurring to inform policy making. That's why we're having the session, to look at the like how to do approach 3, spatial mapping of land use change in fluxes. And so this fits neatly into our objective of doing the spatial analysis. Fits neatly into that. The goal is to create 30-meter global maps of forest-related greenhouse gas fluxes by combining IPCC national greenhouse gas inventory methods with spatial data on forests. And from that, we simulate forest greenhouse gas fluxes at 30 meters, currently from 2001 to 2020. We get gross emissions, gross removals, and net greenhouse gas flux, which is the difference between emissions and removals. The schematic on the right just sort of shows how we overlay a variety of data, and then these are combined basically pixel by pixel for using national greenhouse gas inventory rules. Some of the data that we use, soil carbon, modus burned area, mangrove extent, you can see them here. There are many others that aren't shown here. The point is, well, there are a few points here. One is that these data many of these layers didn't exist more than a few years ago, and therefore, we really couldn't have done this work until they existed. Second is that a lot of these have to do with carbon and forest monitoring in some way, obviously, but combined in this inventory framework, they become even more powerful and are provided some additional context and use, which their foundational papers often describe. So we hope that we've provided sort of a broader context and use for much of this research, as well as any other research that has used them, of course. Third, the model currently, for its default version, uses all of these inputs and others, but it can use other inputs instead. And I'll come back to this later, but this is a key point of how we think that this model can work and live in CEPL. We've created a inventory framework, and as better data sets become available, or if different users want to use different inputs, like a different peat map, their own plantations, their own tree cover loss or gain, they should be able to substitute that into the model for whatever area they're interested in, whether it's a global model or a specific country or a province, and run the model with their own inputs instead. Hence, this is flexible. So, quick overview of the kinds of results we get. So here's a global map of emissions at a somewhat coarser resolution from what we actually output. This is about 4 by 4 kilometers instead of 30 by 30 meters. And this is emissions. You can see the emissions in sort of the usual suspect areas, the Arctic deforestation in Brazil, Southeast Asia, but also areas that have a lot of forestry and plantations like the Southeast US, and then areas that have a lot of fires like the Pacific Northwest of the United States and Siberia. So those are some highlights. Probably nothing particularly new there in where emissions are occurring. In terms of removals, not surprisingly, as forest grows, it continues to remove carbon. So we see a lot of green where the removals are occurring on this map. And the darker green is greater removals over 20 years, or greater average removals over 20 years. A lot of this has to do with the ecozone that forests are in, because there's pretty little data about where removals are occurring in any sort of spatial sense. And then if you combine the emissions and removals, you can see that where areas are net sources, which are the purple magenta colors, versus net sinks, which are the green colors. And most forests are net sinks in general, exceptions being, Arctic deforestation, some of the shifting agriculture areas in the Congo Basin, heat conversion areas in Southeast Asia, and then, some forestry and fire areas, again, in the Southeast US, in Siberia, and so on. So those are some highlights from this. That was the overview of the sort of the original work. I'm going to switch to a demo in CEPL. So I guess before starting on this, I want to note that the model, it's global, it runs at 30 by 30 meters. And so it involves about 90 billion pixels for its full run, which is a huge amount of data, can't be processed locally. So the model runs on Amazon Web Services on on-demand computer, cloud computers, very much like what's available in CEPL, but up here with these kinds of options for instances. And so making the model run in CEPL in a machine like this, instead of directly in an Amazon Web Services instance, is pretty straightforward. With Eric Lindquist's help, I've gotten it pretty much working. There's still some fine tuning to do to make it like the model like logging and command line interface a bit easier to use. And then I know not everyone is comfortable using command line interfaces. And so eventually the next step would be to make a nicer interface like we've seen from other tools. But so far we're still at the stage of using command line interface. And I think that's probably ultimately going to always be the easiest way to use this tool, but you can eventually wrap it with some nicer interface. So yeah, so right now it's a Python model. There's several different command line arguments. I don't have to go through what all of them are, of course. One thing I want to point out is that you can choose what tiles you want to run. The model is divided into 10 by 10 degree tiles for the entire world. And so if someone is interested in running the model for just their specific country or province, they could select the tiles that they want to run. This one is part of Indonesia, 0 north, 110 degrees east. And so just run the specific tiles that they're interested in rather than running the entire world. Can tell whether you want to have the emissions be from biomass and soil, or the other option is just soil. If you want to know the emissions from just biomass, you'd have to run both and take the difference, unfortunately. Then there's various stages to the model with like getting how old the forest is, applying different removal factors, calculating gross removals, calculating the carbon pools when emissions occur, calculating emissions, and so on. And so you can choose which stages you want to run in the model here in case you're only interested in you've made some changes to the model and only affects sort of like emissions onwards. You could say, change it to do emissions and the following steps rather than running the entire model to save time and processing and so on. And then there's a log that gets output. I'll show a screenshot of this in a bit. And so this way you can always note what you're doing in the run. Like, this is a test run. I just added this feature. This is the definitive model run that I'm going to be putting online or something like that to help document it. And then hopefully it'll work because I just tried this an hour ago. I'm not going to leave it running the entire time, of course, but oh yeah, Zoom slows it down. Well, okay, good, it's going. So it does, there's like some preliminary checks. It downloads data from Amazon Web Services, which it's already done. To speed up the demo, it's not downloading. And then it starts on the first step of the model, which in this case is like deciding which pixels are included in the model and which pixels are not part of the model. And then, just goes from like one step to another. So I'm not going to leave it up for this. The entire global model on a 96 processor Amazon Web Services machine takes 7 hours or so, but doing this for a country would, depending on the size of the country, could be, a few hours. Okay, so basically, so hopefully that shows that, like there's the interface works in SQL and, it starts running, it'll keep running. I've mentioned that there's this log. This is actually partially in response to what Gilberto said yesterday about like reproducibility. So here's a screenshot of it. And it, like has all the different command line parameters that people input, the number of instances that the machine is using. And, then it just like basically puts the same stuff that was in the console to here. And you can save this forever, to demonstrate exactly what situation you were doing your model run in. Then, so more specifically to like what we're hoping to do with SQL and where this is in an operational sense. So we've already run the model. We published it with data from 2001 to 2019. We quickly updated it for 2001 to 2020 when new Hansen tree cover loss data became available. And so that's what the two maps are here. So we know that we can quickly update it, rerun it. But the data is available on Global Forest Watch for people to visualize, for people to download the 30 by 30 rasters that they can do their own mapping and analysis with. We have pre-calculated statistics on Global Forest Watch, so people don't need to run the standard model themselves. Like the outputs are there. pre-visualized, with calculated statistics. We have good tools in Global Forest Watch for that. But what we want people to be able to do in CEPL is to add their own, substitute in their own data instead, if they're interested in putting in their own tree cover loss, or own their own biomass map, or a different peat layer, or a few different layers, or they want to change some constants or something, the emission factors. We want that to be easy. This would look a little bit better if I had presentation mode and could do the animation, but this, I think, will still show the idea. So it goes back to what I said about the flexible data integration framework. In the paper, we published a sensitivity analysis to show how the model responds to changing model. Someone just asked about sensitivity analysis. Yes, so we swapped out 7 different layers and changed 7 different model parameters. And so I'm showing 3 of them here. Some of it was global changes. So we changed some global model constants in this top left one. We changed the biomass map in this middle one to one from Sasan Sachi. And then in the bottom right, we used Protus tree cover loss instead of the Hansen tree cover loss to see how the model changes. And I'm not going to go into the results for them, but the point is, we've developed a framework that is able to swap the layers. It's not that easy yet. I can do it. It'd be harder for other people. We have some people, other users, who are working on this. There's a PhD student at Wageningen who's doing this. And I'm learning a lot from his experience about how to run it and what sort of issues he's encountering with changing model data. We're also working with Minam in Peru to customize the model for Peru specifically, which we're really excited about. And that's all. So that'll be a demonstration of they're adding 3 different layers they want to use instead of the global defaults. And so I'm learning a lot from that as well. So I think sort of the next step is to make it easier for people to swap in whatever layers they're interested in. Of course, people will still always have to do some of the pre-processing themselves, I think. But we want to make it easy once they have the data in the right sort of format to be able to throw it into the model and basically do this kind of sensitivity analysis themselves, except that'll be their standard model instead of some sort of model performance analysis like what we've done. I think that covers everything. So I can take any questions or we can move on, but thank you very much.
Excellent. Thank you, David. That was very, very interesting. You've generated quite a bit of discussion in both the chat and the Q&A box. So I might just go to a couple of these now before we take our first break. But the question from Franz Eugene was, can this carbon flux model be tailored to individual country boundaries and specific time frames in order to compare the results with forest reference levels of countries? I think the comparison with forest reference levels will be difficult, given that there'll be all sorts of different definitions and everything being used, but individual country boundaries, can that be done? So
yes, I mean, people can already download data, the standard model that we published. They can download the original outputs from it and analyze those for their countries. If they have a specific forest definition based on tree cover, they can apply that to the output. So, filter it by Hansen tree cover density. If their tree cover density is 50% for forest instead of 30% or 40% or 10% or something, they could, filter our standard output by tree cover density. And then if they're, if they want to rerun the model for their own country with a different definition of forest, and they have some, country specific forest map or tree cover loss map, or biomass or peat or, or mangroves or whatever else they think is really important for their country and want to use that instead, that's what we're shooting for, to allow people to make it easy to include that in the model instead of what we're already using. And there's going to be some extra steps to make it usable for a FREL, but our goal is to have this either be usable for a FREL or sort of like a external check for a FREL that a country or someone else could use it, using an alternative approach, basically.
Excellent. Thanks, David. There's a question in the chat from Thelma as well. Apologies if you did mention this in your presentation after the question was asked. I was a bit too busy trolling through the questions. I'm not very good at multitasking, but She asked, have you estimated the accuracy of these products or conducted any validation?
Have we estimated the accuracy of the products or performed validation? We have not done a strict accuracy assessment of it. We have done an uncertainty analysis by for the entire planet and by climate domain, temperate, tropical, boreal, and subtropical, using IPCC error propagation approach, basically, so that for each domain and each flux, emissions, removals, net flux, we have an estimate of uncertainty as a standard deviation of the model estimate. There's definitely a lot more that we can do with uncertainty, as with just model improvements in general. And so we welcome any collaboration on this, whether it's improved, if you know of a new layer that you think would be better than what we have already, let us know. If you have ideas for how to approach the uncertainty analysis for this, or some way to do site validation, that'd be great. It would be wonderful if we could do some site validation for sure.
Excellent, thanks, David. Thelma, you're a panelist. Did you want to follow up to that at all? You'll need to unmute yourself if you do, but I'll pause for a moment. Nope. Okay, we can maybe come back to that one later. And then there was another question from Laron. What data is missing, or quality of data missing, to improve your models?
Yeah, it's a good question. So the uncertainty analysis showed us that the single biggest problem in our model is with tree cover gain / removal factors. And I think that's no surprise for people who try to monitor carbon gain or forest increase, right? It's harder than loss. There's no good spatial global data for tree cover gain right now that's fully up to date. And so that's definitely a limitation. We mentioned that in the paper. And then in terms of removal factors, we did what we could to combine a variety of different removal factors, but we're still using IPCC tier 1 defaults for a large part of the world. And some of those IPCC tier 1 default removal factors have really high uncertainties because they're just not based on all that many plots. And so we have some pretty high uncertainty from that. So I'd say removal factors and improved tree cover gain data. Those should improve over time, but they're still certainly the weakest part of the model, unfortunately.
Excellent. Thanks, David. That is very useful. You've certainly stimulated some good discussion here. That's always a sign of a good presentation. So well done. I think what we will do now is we will take our 10-minute break. But there are, for your information, David, a couple of questions outstanding still in the Q&A, and please do look under the answered tab as well, because I may have accidentally marked a couple of them answered when we didn't quite get to them. So
Sure.
Please do that. And then I think we're going to take a little 10-minute break. Sarah, is that correct? You're happy with 10 minutes?
Sure. There's more questions on the chat for David as well from Adam. You can see those. But yeah, we can have even a 15 minutes break if you need, which means we will finish just at the regular time instead of 2:30. So we have some freedom. But yeah, let's get back at 1:10.
10 minutes past the hour. Fantastic.
Yes. Okay.
Sounds good. Well, thank you to our presenters thus far. Very, very good start to the day, and looking forward to the demonstrations. So hopefully I'm fully fueled for the rest of the workshop, but looking forward to cracking on and getting into the next demonstration, which is by Andreas on the Forest Canopy Disturbance Monitoring, Fcdm. Over to you, Andreas.
Okay, thank you, Tom. So first of all, question, can you hear me and can you now see my screen?
Yes.
Wonderful. Okay, so I will try
Just
to
remember
give a
to
presentation.
play the slides there as well.
Yes.
Yeah, excellent.
It's fine? Wonderful. Okay, so first of all, welcome to all of you and thanks for having me there. So with this slide and this presentation, I would like to introduce you the Forest Canopy Disturbance Monitoring Tool, or FCDM tool, which basically incorporates two monitoring approaches, an optical and a radar-based monitoring approach. And this was developed under Recaret project here. Sorry, I totally forgot. I'm working at the JRC, the Joint Research Center of the European Commission. Okay. So first of all, some words regarding the challenges of monitoring disturbances, what it's all about. Generally, one moment. Forest disturbances, of course, can be deforestation or smaller scale disturbances, which I call here now degradation. The deforestation, the larger clear cuts or patches, they are comparable, easy to detect. The focus of the Fcdm approach is mainly on the smaller scale disturbances. However, you can get both of them, but the focus I would like to put here is here on the smaller scale events, which could be, for example, logging roads as you see them here, but even more so, ideally, single tree extraction. So really what is going on a very small scale. And so the problems are, on the one hand side, you're looking at as I said, like very small scale signals from a very small scale, and very often very weak signals. And especially regarding these optical monitoring approach of Fcdm, the signal is often only detectable over a short period due to either the fast vegetation regrowth, or not either, but as well as often the situation of a frequent cloud coverage, especially in the humid tropics. And on top of that, you also have to differentiate between natural phenological changes, such as, for example, leaf shedding due to seasonality, and actual disturbance events. It's also something which is mainly the optical one concerned, where the radar is superior, but we'll come to that later. So basically, Fcdm targets the detection of small-scale and short-duration disturbances that are up to now not in that detail detected by other existing approaches. Okay, so here you see the graphical user interface of the Fcdm tool as implemented in Google Earth Engine. When you run it, so on the one hand side, you have the parameters to be entered, and then of course you have the mapping result. Here we see an example of Papua New Guinea. In red we see logging roads, or the impact of logging roads, and most probably selective logging in that area. That's based here on a combination of Landsat 7 and 8. So that's the tool itself, and that tool has, as I said before, these two monitoring approaches. The optical one, which can use the different sensors from Landsat, as well as Sentinel-2. And then there's a new approach, the radar one, using Sentinel-1. The optical one, or the underlying methodology, has been published in that paper. Here I give you also a link to the paper. This was 2018 already. And the script to that tool is also, since that time, freely available. It has been further developed. And but for this optical approach, it is accessible for free and online, so it's totally transparent. Regarding the Fcdm radar approach, we're working on a publication after that. It's so I will show you now the tool with the radar approach as well. It's implemented here as well, and it will be available as well for free download. So now let me see if I can manage to. I hope you see now my screen and you see Google Earth Engine.
Yes.
Okay, wonderful, thanks. So that's the tool, it's the latest version, which includes not just the optical, but also the radar-based approach. And I rely that Google won't let me down. I think it won't let me down, but I will start it now, and then I will switch back to my presentation, continue, and then we see, and keep the fingers crossed that we will see something. Okay, So for this example, I thought I will give you the analysis of the country of Gabon, just because it's, to my opinion, it's a very tricky country to be monitored when monitoring, for example, with optical data because of this frequent cloud coverage. And here in this example, I would like to show you the Fcdm radar-based approach, which of course then clouds are not an issue. However, with radar, you know, there's the issue when you are more in a hilly area. It's more rough topography. So therefore, I will try to focus here on this area. But anyway, it's for the whole thing. There are quite some parameters to be entered, but if we keep the default one, everything is fine. So basically, what is done? So here I will just maybe. You can say whatever area you either can upload a shapefile, you can draw a region of interest, or you can select from this list whatever country you want. So if I say for Gabon, then Gabon is selected. We keep with here. It's also working within a forest mask. You can say also you want no forest mask, or you want another forest mask. Right now, it's using the global forest cover. Here, using 2019 as a base map with a 30% coverage. And within what is there defined is then forest, this algorithm runs. And as I said also before, instead of going for this Landsat or Sentinel-2 data, we go for Sentinel-1. That's basically all for now. Let's hit run and come back to hopefully my presentation. You see back my presentation, I think. Okay. Okay, so what's the basic concept of these two Fcdm methodologies? So underlying is in both cases a change detection approach. And I thought also for this presentation, I will not go too much in technical detail, but just really the very basics. So, so the very idea is to say you have at 2 points in time, you look at the canopy condition of a forest for the reference time, and which is further back in time, and for another point in time for the analysis scene, if you want. And you calculate between these, in a simplified way, the difference to see what happened if changes in the canopy conditions between the reference and the analysis. Okay. A little bit more complicated, what Fcdm does is not to look at single points in time, but to look at periods. So in the example we just started with Gabon, I chose a year, calendar year. So you will later see, hopefully, the results of the changes that happened in the year 2020. This would be then our analysis period, as compared to the situation 1 year before, 2019. And what Fcdm does is it analyzes the canopy conditions. So it fetches all available, in this case now with Sentinel-1 scenes, analyzes the canopy conditions and accumulates them into some intermediate result of the accumulated canopy condition for the reference, and the same is done for the analysis period. And these two conditions are then compared to each other, and the change is derived. And what does this change mean, or yeah? So as I said, like, it's a change detection approach, meaning that if in the reference period we have no canopy opening for a certain pixel location, however, during the analysis some logging occurred, pixel was opened, we get a disturbance event. For the opposite, maybe there was a canopy opening during the reference, but later it closed again, we get a regrowth event. And then we have these two cases where there's no change. So either there has been, or let's start with this, of course, it's maybe easier. If there has been no disturbance or no canopy opening in the reference and in the analysis period, of course, no change. But also if we have opening already in the reference period, and this opening is still persistent in the analysis period, we also get no change. This is very important to know. This means also that that approach doesn't give you necessarily the status of a forest of the analyzed period, but the activity data, only what happened within the analysis period. Let me shortly switch to, okay, at least it's working, running, okay, good. Yeah, so it gives you the change, what happened during the analysis period. Okay. Now I put you some slides as comparisons for different monitoring approaches. So here, this example, I show, or we look at a planet imagery, a 3-meter spatial resolution, just for us as a visual reference. It's an area in Cameroon. It's a logging concession. And this planet scene was derived at the end of 2020. And here, in this case, we also analyzed the calendar year 2020. So here we have basically a reference, a visual reference towards the end of that period. So what we see is, of course, here some roads, some agricultural areas. But this forested area here, you can already here see in this 3-meter data, you see roads crisscrossing the forest, so logging roads, smaller logging roads. And if we look at Global Forest Watch data and look at the loss, only the loss in 2020, not what happened before, but it's an active concession. So it's again about what is going on. We get these indications here in white. If we look at the GLAD alerts for the same period, we get this result. So you see they catch partly these logging roads, these, of course, small logging roads. If I move on, TMF, it's another data set which is freshly out. It's from the JSC, it's Tropical Moist Forest, analyzing historic data. But again, if we focus only what happened in this last year, 2020, we get these results. We see even more these logging roads. And some very interesting data set, I think, is also the RAT alerts. These are able, they are based on radar data, on Sentinel-1 data as well. They are even better able to detect these logging roads. But on top of that, you see here these single groups of pixels, which most probably refer to extractions of trees. For a moment, let me just shortly check our result. Ah, wonderful. Okay, I see something, and I would like now, on the one hand side, again move to that area. Yeah, let's look at this. Okay. Yes. So here we see these parts of these single tree extractions, and now, opposed to that, I would like to show you these results from Fcdm. First, the optical-based approach using Landsat 7 and Landsat 8. So we see also here these roads and some pixels in between. And here's the result now. Again, the optical Fcdm using Sentinel-2 at a 10-meter spatial resolution. Of course, the Landsat comes with 30-meter. So we see very nicely these roads, and we see also some impact from most probably the tree extractions. Both of these, also this basic Fcdm optical, just also for your information, it's right in the moment in the process of implementation in CEPAL via FAO CAFI. As far as I understood, Remy, it's not yet finalized. Therefore, I go for the presentation in Google Earth Engine. Okay, and here, last but not least, we have the Fcdm radar result. So based on Sentinel-1 data, we see again these roads, but what we see on top is many more of these single tree extractions in close vicinity to these roads. And this FAO CAFI said once the methodology is published, they also will be interested to look at it for implementation, for possible implementation. Okay. Now just a short comparison here. I put together on the left-hand side, you see the monitoring approaches, Global Forest Watch, GLAD, TMF, and RAT superimposed on each other for the year 2020. And on the right-hand side, you have the Sentinel-2 based and Sentinel-1 based, so optical and radar put on top of each other. And you see the higher detail with a Fcdm approach. Here just shown for some area where we found some very high resolution data in Google Earth Engine before the event in 15. Again, as I said, like here, it's 2020 is looked at. And at the end of 2020, we see these openings. Just some short words about the documentation. So there is documentation out. You find in these links. You can also download. Anyway, I gave before the link directly to the script, but you can also find here the link to the script and also some documentation. However, here I have to admit we have to work on this. It still has to be brought to the updated version. And last but not least, my final slide. The applications, the already existing applications of Fcdm. So there is in Vietnam, VP uses it as one processing step for revising all cycles of NFIs. In Laos, the Department of Forest Inspection asked for training on province level, and the Forest Inventory and Planning Division, as well as together with JICA or Japan as a FRET and USA Silver Carbon, they test whether this Fcdm can replace field degradation monitoring. And there's also ProFlect from GIZ Germany and Avuna Technology looking at Fcdm or incorporating it into something which is called ODM, Operation Logging and Degradation Monitoring. In Cambodia, the Ministry of Environment underlined their interest in further training. So they got already trainings during this project. And another project together with Copenhagen University and Denmark, they use already this radar data, which we provide basically to look at protected areas and what's going on. Thailand, Myanmar, they showed interest in training. Indonesia also thought it might be a suitable replacement for visual and manual monitoring of degradation, and they asked for workshops. And during a Red Copernicus project here at the EU, the Fcdm approaches were used to develop products for a further Red Copernicus service component for monitoring degradation. And as I mentioned before, this implementation or the step, the process of being implemented is from FAO CAFI in progress. So now, if I have some short minute, let me just show you. Now we see the results. So first of all, just we can click this and that's the way. So we see we are within this very rugged terrain, but we see some let's do like this, some signal. And now I would like to point you here. I have the Sentinel-2 Explorer. It's just to show you the same area that you do not think I made this up. So this is from, when is this, from February 2020. We see basically this road starting was in February, 18th of February, it was already that far. Before or after, it's always cloudy. So, and then I looked at the, was it 12 or 9? It's also quite cloudy, but this is from December 2020. We see that this logging road went in so far, and whoops, so we see it's spreading up here in this like fingers, and this is what you see here. However, what you see also, it's very coarse, and as you see here, you have a lot of parameters. Several of these parameters refer to a filtering process, and this I would like to also switch on. The user has, of course, the possibility either to change the script itself or to have the hands on all these parameters. And so now I will, you see basically the, one moment, yeah, it's coming up, yeah. So you see now that's the that's the raw data coming. You see the signal, but you see quite some noise around. And if I switch on this, I hope you can see this via this online presentation. You see that this noise gets filtered out and only the large patches, larger, they are still small scale, are kept. That's basically what I would like to show you, and I think I'm already way over time.
Excellent, thank you, Andreas. That was very interesting, and that has been reflected in quite a few questions rolling through for you in the Q&A. We have a couple of minutes before we need to move on to the next one, so I'll fire a couple of these questions at you now, and then I'll ask you to follow up in writing afterwards. The first one I want to go to is from Wesley Roberts. With regards to the Fcdm tool, have you run any tests in dryland environments?
Yes, so that's the whole issue. So with the Fcdm, as I said, like optical and radar, the optical one is supposed to work within evergreen, semi-evergreen forests. If we come to dry environments or leaf shed, as anything which shows some seasonality, the algorithm as it is programmed will show up in false positives for the optical approach, not so the radar-based approach. Here I can point you to a paper. It's a technical report we brought out in for Cambodia for some area which is a combination of evergreen and then going into the deciduous. It's Prey Lang, it's in the central part of Cambodia, and there we have some results. This I can put them in the chat also, and there have been also under this project I mentioned this Red Copernicus, where Fcdm was analyzed to see what features could be used for a future component, Copernicus monitoring component, and there it was analyzed also in dryish areas in Africa. However, without us, so there's not a paper, not a result I can share with you, but I can say yes, it is working. But I will share the other one. However, the dry component is certainly an issue, and this was also one of the points where we wanted to get out this radar base.
Excellent, thank you, Andreas. Please do post those links. There was another question which Remy has partially answered, but is there a link to the GEE app version of the Fcdm tool that can be shared? Remy, did you want to just speak briefly to the comment you've made there about this coming up in CEPL?
Yeah, sure thing. Yeah, I just want to say we've worked with Andreas and some of our developers in the team. Again, Pierrick has been pivotal in this to adapt the Earth Engine script that GRC has developed and to put it into a wrapper inside CEPL. It's going to be released next week with the next reroll. So, you know, it's always a question of timing, but it's ready, it's there. It's just when we release reroll CEPL, it just comes as like a big batches with like new features, and this module will be part of this one. And as any of the modules that are inside CEPL, the source code is directly accessible. I believe Eric answered earlier on the similar question that was related to the WRI. GHG fluxes, and send the link to those. We will put the link to this one. But maybe Andreas, you already want to share the GE script itself. I don't know how it stands.
The GE script for the optical one, you found it there was directly the link in the presentation, and of course with this GitHub. Yeah, I have to also update this for the latest version. But anyway, this you can access. And the radar-based, as I said, like once this publication is out, it will be available as well. And anyway, yeah. So this you will find not yet. When you click this link, it's version 2.4.1. That link where it is given in the presentation, which allows you to work with a Landsat 4578 as well as Sentinel-2, and the other functionalities of these spatial filtering, which I showed you. This is all included. It's just the radar component is not yet in.
Excellent. Thank you, Andreas and Remy. I just want to do one last question before we move on to Dario. But this is from Tumas in the chat. When you extend the reference and particularly the analysis time periods, have you observed underestimation of disturbance because of vegetation succession?
So I think the point is more if you shorten these periods, it gets more problematic due to the fact that the level of noise gets higher. So maybe there's some, so on the one hand side, of course, the analysis period should cover the time when the activity is there, basically. Yeah? So if you extend it or whatever, and or you choose a period where there's no activity, it will not give you a result. So this is also what I try to stress in this presentation. It's not that, for example, just the area we looked at, if there is not a red pixel, whatever, it does not mean it's pristine forest. It could have been degraded 1 year, 2 years before. However, what is happening within that period is supposed to be captured. And normally making it shorter is more problematic. There you have to change other settings, and you can shorten it, and also you can move it. This is maybe also some interesting point. You can move it more towards near real-time monitoring as it is now. I should have some word on this. But you will, up to now, you lose the spatial detail, which I'm happy to show. That there's some add-on. So for example, this comparison with these RAD alerts, which I think is a very, very good data set. Fcdm is able to catch more spatial detail, but Fcdm is not, the radar-based approach, is not able to go that near real time. Because for me, I need an additional period. So in this example I showed you, if you look at 1 year, for example, from 1 year of monitoring, I need another 3 months to confirm or reject alerts. So therefore, getting below 1 month or a week or whatever towards near real-time monitoring, you would lose spatial detail.
Excellent. Thank you, Andreas. That's very useful. We are sadly out of time. There's a few more questions I'd like to put to you, but I'll have to ask you to respond to those in writing in the Q&A box. So thank you again, Andreas. That was very interesting, and look forward to continuing to discuss with you later on. So next up, we have Dario Simonetti, who's going to talk about the Sentinel-2 cloud-free annual composites for RED+. Over to you, Dario.
Okay, so thanks, Tom. Okay, let me share my screen. Okay, so it's Dario Simonetti from the Joint Research Center speaking. And hope you see my screen with the presentation.
Yes, it's played now. Perfect.
Okay, so today I want to just briefly describe the methodology and the dataset we have generated called the Sentinel-2 L1C Cloud-Free Composite. It's an annual composite based on 15, 17 together due to the scarcity of Sentinel-2 dataset, 18, 19, and 20. So the question is, the question of this main slide is, what is this product? Well, this product is a 20-meter resolution pre-computed composite or composites based on SWIR, NIR, and red bands, able enough to extract some indices like NDVI, NDWI, or other vegetation indices. And each composite is about 0.5 terabytes because of the reduced resolution. So it's quite manageable and it's ready to use. It means that you can simply navigate the website and access the data. So you don't have to compute yourself or to download individual images. There is, as I said, a dedicated web browser as well as WMS service in order to embed this composite or the potential annual change layer into your GIS application or website as well. And you can also download the GeoTIFF files corresponding to each tile. But let's jump to a next question, that is why we built up all this system. So this is a brief excursus from January 2016, when we received, actually in October 15, but the first Sentinel-2 images. So we were collaborating with a lot of record countries, and we thought, okay, how can we serve Sentinel-2 images that are huge? At the beginning, they were coming in big files like 4 gigabytes. So how comes that in developing countries, we can use such a big data in one single image? So at the beginning, we developed a platform to distribute individual images to our partners and collaboration organizations. So and as you can see from some awards, like LCMRD, that is an institution in Africa, is the first institutions providing Sentinel-2 data for 10 countries. So, okay, so these great achievements early 2016 were okay, but there is always a but. There are still single images. So how to analyze a land cover change over different periods? For instance, you have an image or a set of images coming from Kiribati Island in the Pacific, where you see the amount of clouds, and those are just the best images, the best 12 images available for 1 year. So we thought, okay, it's not gonna work, even though we distribute all these nice features, website services, and so on. So the idea then came with the amount of availability, the Sentinel-2 data availability, making composite. So in 2016, ESA developed the first cloud-free composite over South Africa. In 2017, the JSC, as proposed by Thomas Kempner, developed and distribute another data set, another composite. And recently in 17-18, again, another composite by Corban et al. And why not mentioning the S2GM, that is a service built up on top of the Copernicus services. But as you can see, there are a lot of services, a lot of maps, available maps. But again, another but, those composites are affected by tiling. As you can see, the different methods, 25th percentiles, or best image over the, in this case, East Africa, are not making a smooth and cloud-free composite usable in any kind of change detection algorithm. But also with the new service based on L2A. L2A is the top of atmosphere reflectance. It means that this product is coming after applying a lot of filterings. It's coming directly from ESA. But as you can see from the S2GM method used based on this product, we have a lot of overcorrections due to the model used and the elevation model used. So again, those solutions are not optimal. So at the beginning, I thought, why not applying our every single pixel of Landsat Sentinel rapid eye data? We have developed and distributed these applications, this algorithm, to Sentinel-2 data. And this is the result. So in 2018, we start ourselves with very simple solutions like L1C products, so top of atmosphere reflectance. I might be, I was probably wrong at the beginning. L2A here, it's a surface reflectance. So it's supposed to remove any contamination introduced by the atmosphere. While in our case, we are just looking at L1C, that is the top of atmosphere, so at the satellite reflectance. So as you can see from the evolution, 18 and 19 and 2020, we try to remove, or better, reduce the radiometric issue in order to smooth the classification and change detection analysis. So we also adopt a kind of orbit normalization or equalization in order to remove this kind of annoying striping effect. So the idea at the end is to generate a smooth cloud-free composite for different epochs, and also calculate on the fly some change detection analysis so that everybody can just browse the map and spot some degradation or deforestation, or why not also regreening, let's hope. So those are very few examples based on Malaysia, where we can see in green the regreening, and in violet the loss of vegetation, in this case is forest, has identified by the change detection layer. I will show you later on during the slides. But also those are very big scale deforestation patches, but also very small scale deforestation, for instance, in Madagascar, where the remaining forest has been somehow chopped down by in pieces, and also slowly. So this map has great potential for identifying and also visually spot some numbers. And when we use the composite, for instance, in 2019, we received a request to demonstrate, or to check this huge amount of fires reported in August 2019. So I launched the processing in Google Earth Engine. So this cloud and shadow mask algorithm has been implemented in Google Earth Engine as well. And the 1st of September, so almost 2 days after, the map was already on our website with the fire overimposed, the fire from the active fire, the Modis active fire was overimposed on the map. So it means that we got 36 tiles from Google Earth Engine, downloaded in processed and downloaded and put on the web in just 2 days for the verification approach. Then we wrote also some technical reports based on these observations. But just to give you a number, the composite with the reduced size of 20 meter and 3 bands was about 94 gigabytes. So it's a quite reasonable amount of data for such a big country. So in brief, to make a resume of what we have done and what we have in-house is a website describing the product, some references, so the paper, including the data set, the link to the website, and also the source code of the cloud mask has been submitted to the data in brief. We have a browser, a download options, and the Google Earth Engine script that everybody can easily customize. But the most important thing is the integration into CEPAL. Honestly, I didn't have so much time to test it, but I would like to thank the CEPAL team, including Remy, Eric, and Daniel, that were giving me support to set up the environment and to test the classification algorithm in CEPAL as well. I don't have any idea about the delivery, the official delivery date, but I guess it's almost ready and will be soon released in CEPAL as well. This is the website, and what I can easily show you is like a quick demonstration on how it works and what you can see. So here we are in Brazil, yes, south of Manaus, and I can see some deforestation. Oh, sorry, I can see the base map in 2015-17, and I can also overimpose the 18 and then the 19 layer and 2000 layer. But okay, then all those reddish areas are burnt areas after the deforestation. But most important, what you can see is a change detection layer based on different epochs. So 1520, but if you want to see recent changes, you can just change the drop-down menu. And so all those areas are in red, are areas deforested legally or illegally, we don't know, in 2020. So in order to see and to prove what is happening, it's enough to visualize the base map 19 and the 20, where the red patches are appearing. So similarly, I can also jump to other locations in order to show you, for instance, in PNG, Papua New Guinea. Last week we received a request showing some Sentinel-2 data because of illegal or actual roads entering in the forest in a protected areas. And thanks to the Sentinel-2 composite, I could easily spot them out. So, for instance, just showing the changes between 18 and 19, I could see, oh, the network is a little bit slow. I could see the changes. So actually this is 20 and this is 19. So you see the big roads going into the forest. And similarly to what Andreas Lackner is doing, we can visually spot those changes and overlay the Fcdm results on top of it to prove if the detection is correct or not. But the tool is not only good for local scale, it's and forest or vegetation. But let's jump, for instance, to Kenya. Kenya, or Tanzania in this case, is surprisingly green in 2020. And if I zoom in, I can see in 15 the size of this lake, and then jumping in 19 and 20, I can see the increase of the water amount in those regions. And this is also supported by a communication received last week about the raising of several lakes in Kenya as well, causing people displacements, crops disasters, and so on. So again, this tool it's actually is a data set, but the cloud mask implementation, it's a free and open source. It's a free tool that is sent to the CIPAL team in order to make this composite available to every user in CIPAL and also Google Earth Engine, and also giving the possibility to change the settings, the period or the time frame they want. So I think that's all from my side.
Excellent. Thank you very much, Dario. Likewise, you've triggered quite a bit of interest in the Q&A, including big props from Emil, who says, kudos, Dario, for all the technical details. This presentation is awesome, in all caps. Speaking of awesome, for those of you who don't know, behind Dario is a 3D map of the world, which he made with himself with polystyrene, which I think is very impressive. I presume it's to scale as well, right, Dario?
Yeah, this is just a demonstration that a simple cloud shadow algorithm can do great things with the amount of data. Eric yesterday was saying we are in a situation, we are in an era where we are submerged by data. But when I started, I was processing data from the DLT tape. So, so this is the big advantage of our era, but we need to develop algorithm to build on top of those satellite data, because we can generate very cool maps usable for change detection analysis.
Excellent, thanks, Dario. So while you maybe take the chance to scroll through the Q&A, I might just ask Eric Lindquist to turn on his microphone and maybe speak to the comment he just put in the chat for everybody's benefits, just to show the links to people here. Eric, do you mind?
Yeah, sure. Thanks, Tom, and thank you, Dario. Thank you, JRC, for contributing this code. It's great. And so yeah, because we can work closely with Dario, because of the way the platforms are flexible, and because it also relies on Google Earth Engine in the backdrop, we're able to easily integrate code like Dario's code for cloud masking and compositing into our existing cloud masking and compositing algorithms within CPL. Put a button on the CPL interface that says, I want to use Dario's method, in combination with other methods or by itself, whatever way works best, or you can experiment with all the different ways all at the same time. That button will be in CPL as of the next release, which will enable you to apply the JRC cloud masking algorithm to Sentinel-2, which will, as I put in the chat, enable like fully BRDF corrected Sentinel-2 composites for anywhere in the world at any time period. And yeah, it's going to be pretty awesome.
Excellent. Thank you very much, Eric. So Dario, a question here from Laron. How many users are currently accessing these great cloud-free composites?
Well, good questions. The composite has been distributed to several institutions already as a physical data set. We are not tracking access to our website due to the number of accesses. Yes, we know, but we don't know who is actually accessing the website due to commission's rules on privacy and so on. So honestly, I cannot tell you because several users. Don't forget that this composite is accessible as a WMS as well, so you can easily embed on your QGIS, ArcMap, or on your website. Recently, we have included into the Brazilian data cube easily together with some other products from the JSC, like the TMF and so on. So you can easily integrate the products into different applications. So it's difficult to track and monitor how many users are actually accessing the composite or using the composite, downloading the tiles for building land cover change analysis.
Excellent. Thank you, Dario. Nice to know that not everything is being tracked on the internet. It's quite refreshing. A question here from Alfonso. Are these composites being used for the CCI LC maps at 20 meters?
No, I don't think so, because this composite has been developed as a quick response to our partners in dealing with and also forest services, forest service in the tropical countries, in order to overcome the limitation of clouds over that area using the optical satellite data. Again, this is a 20-meter composite just as a demonstration, also for easy and speed up the MRV process. But don't forget that with CEPAL and also with the Google Earth Engine, you can build and download the 10-meter resolution and also full band and with a full optical depth. So this is just a demonstration on what can be done easily in, let's say, just few months. Every beginning of the new year, the composite is updated to take on board the past year. So it's just a matter of few months in producing one single account, one single process, and one single user to do that. So, and thanks also for my colleagues to build up the website and collect all the and maintain it. So.
Excellent. Okay, Dario, thank you very much for that. There's a question here from Frank. Is there an implementation of Force? I'm not quite sure what Force is. Force is great at producing consistent Sentinel-2 Landsat composites and higher level products. Does that make sense to you, Dario?
I think it's more a question for the CPAL team.
Yeah, sure, I can answer that. No, that we don't implement Force per se at the moment, but it's something like the cool thing is we could do. And we will take a look at it. I mean, we do implement some of the same things that Force seems to do. I haven't used it before, but it is something that we could take a look at and integrate it into the platform. That's the nice thing about it.
Excellent. Thank you very much, Eric. And thank you again, Dario. There are a number of questions left outstanding for you in the Q&A, Dario, which I'll ask you to respond to in writing. We are pressed for time. And again, likewise, if anyone else has any questions we want to put to our presenters, please do continue to post them into the Q&A box. But that draws our demonstrations to a close. So thank you to all of our presenters, our demonstrators, for really adding the substance to this workshop. It's fantastic to see the the scale and breadth of work that you're all doing. It really is very pleasing. So, but now I will pass back to Gilberto, who's going to moderate the discussion. Over to you, Gilberto.
Thanks, Tom, and thanks everybody for a very nice session. I think it is a pleasure. I just want to change my. Okay, so from the point of view of Geosecretariat, this has really been a very, very great event because we really have a huge amount of qualified people who have shown important advances in the state of the art of forest monitoring. So I would going to ask Sarah or Rick to put up a couple of slides that would guide us through the next step of the discussion today. So, or maybe
Rick is going to do that.
Okay, fair enough.
I'm on it.
Thank you.
Do you see it?
Coming. Or at least something. Okay, very good. So just as a reminder, we had, whoops. Okay, we have had 6 software packages developed by different groups, and we have 9 reviewers invited. So we've heard from the software developers, and everybody was extremely pleased. And I'd like to again thank the software developers, the teams for doing their work, but also for their commitments to support SIPO, GEO, and GFOI. Now, of course, we are now relying on our reviewers, which, as you can see by the names, form a very distinguished group of people who have, I mean, between them, enormous experience. So next slide, please. So what's coming next? So here, what has happened is, before the workshop, we contacted the software developers. Can you just put it on a presentation mode? I don't know if it works, but it doesn't. That's okay. So we contacted the software developers to provide the CALM self-assessment. So I hope by now everybody at least on the experts and the presenters has fully understanding of the CALM framework. And we provided access to SIPO, and some of you have shown the demonstration of software capabilities in SIPO, or as in some cases in platforms that SIPO connects to, for example, Google Earth Engine. And we are very fortunate that you could devote your time for that. Now, the next step, you have to remember where we are. This is not a workshop just to say, oh, I'm here, I'm presenting things. It is that we have a community. We have a community to support, and a community which is diverse, which is made of people developing nations and different capabilities. So now comes in our experts, which are going to help GFOI and GEO by assessing the CALM level. So there's a self-assessment done by developers, but there will be an assessment done by the experts who will receive a spreadsheet to that extent. And the most important thing is that, again, I stress what Thomas said in the first day, we're not looking for winners, we're looking for cooperation. We're looking for everybody pitching in, and that's important. So the experts will provide recommendations to the developers on items. First, the most important thing is how to reach, if the packages have not already reached, the higher levels of CALM that will allow them to, of course, be available to the wider community. The other point, and this is what we're going to discuss a little bit today, is how we also, in the meantime, support IPCC. in the IPCC request, which is very important, as you can understand, GEO and gfoi being international organizations whose mandate is to support members to comply with Paris Agreement and other agreements. For us to a call for arms for IPCC is actually a mandate. Then we expect these recommendations to be sent from the experts to Tom as the GFOI office, hopefully soon. I mean, it's something simple, don't elaborate, just please cooperate. But before the end of June to Tom, who is going to then to send each assessment to the developers. Now, what we will want from you, and I don't hope that some of you may make commitments today, but we want a response from you as soon as you receive your assessment to tell us if you are willing to go the next step. Then what's the next step? The next step is the progress towards operational status. So based on the recommendations, what do you need to reach? And at that point, you might also want to contact GFOI and GEO if you are not able by yourself to have the appropriate resource or the resources you deem appropriate to do what it takes to reach the level that has been recommended by the experts. This is where GEO and GFOI come in, because if you say, okay, I want to do it, but I don't have the resources, I don't have the time, but very much I know what is to be done, and then we are going to discuss internally the possibilities for supporting you. And then in 6 months' time, or depending on the discussion today, of course, ideally, we would like to do it by the GFOI plenary, but I think that's too short, but certainly not a plenary in 2022. So we have to allow some time to do it. One possibility is the GEO plenary as a side event, but this is up to the discussion now. That those of you who like to invest or who have the possibility to invest, make it available fully on CIPO. We've seen that a lot of the tools, like for example, Fcdm optical is already there, Fcdm radar may be there already. So we're not going to dictate anything. We hope that you can collaborate. Then I'm going to open the floor. I'm going to just to note two things before we start the discussion. One is an interesting point, comparing the IPCC requests to what was presented. IPCC stated that they want a land class according to the IPCC categories at the minimum. They also talk about the transition map, and they also request means of measuring uncertainty. And that's a topic that was not really discussed today, but I hope that you all can address this. The other point is that the concept of a transition map that IPCC has put together has been superseded by something that comes out of the community which is, I would call, continuous monitoring. There's a recent paper by Curtis called Continuous Monitoring. Curtis will tell you the full title, but I absolutely commend those of you who have not read them. He discusses this from moving from the transition maps to the continuous monitoring, and of course, to our great pleasure, many of the tools that were presented today actually are continuous monitoring tools. Now, 2 points, because to provoke you. We have seen an impressive amount of algorithms. From the point of view of the users, can these algorithms be put together into a broader system so that a user coming into CIPO would have the choice of running Fcdm or Ccdm or whatever and compare the results, and to make it easier? This, of course, requires cooperation between the users, developers, and the CIPO team, but that would be, if possible, a most important advance. Second, what about capacity development what about user uptake? So I'm going to provoke and then open the floor for those of you. Please, those of the panelists, please raise hand, share your views, tell us what you think. And first of all, please address whether we think, how long do you think you need as developers to come to a point that we can really present a very interesting result to the CIPO community? So the floor is open. Thank you. Any takers?
Hey, Gilberto, can I maybe just jump in quickly while people are thinking, just to present a quick overview of, I guess, the framework that GFY is implementing. And also, I've just realized that I'm not sure, I'm just going to share my screen very quickly. Let me know once you can see this. I just realized we maybe for those joining us today, we maybe didn't introduce the CALM framework for all of the participants. So the CALM framework is the criteria for consistently assessing levels of maturity of different products. So it's essentially the framework the GFY uses to ensure that, I guess, the product we're taking to countries are operationally ready. So just to clarify for those who might have missed that yesterday. So I guess it's important to note that obviously, as Gilberto said, we've seen a very nice snapshot of the enormous amount of, I guess, technical work and development work that is going on in our community. And it is, as I said, it is wide and deep. There really is an enormous amount of work that is going on. And GFOI's role is to, I guess, organize this into, I guess, a cohesive package or a cohesive pathway to, I guess, country uptake. So to providing, implementing countries with these tools in a manner that they can be utilized within a complete national forest monitoring system to help them complete their emissions measurement, reporting and verification procedures. And the diagram I'm showing here now is something that is actually hot off the press. We've just finished it today. So even some of my GFY colleagues on the call might not have seen this before, but this is essentially how the GFY framework works in practice, and I think is very relevant to this discussion. So as I mentioned yesterday, it all starts essentially with the MGD, GFY's methods and guidance document, which is really sort of the core syllabus of GFY. It is what links UNFCCC decisions for reporting by countries to IPCC guidance for greenhouse gas inventory. So it puts in place, I guess, that directly relevant guidance for the overarching framework for a national forest monitoring system and associated MRV procedures. Its online platform in Red Compass then provides, I guess, what's a more user-friendly framework for countries to work through the various decisions that they need to make in designing their national forest monitoring system. So this includes a series of decision trees and specific actions that countries need to take in developing their national systems. A platform which we've been working on for a little while and are very soon to launch is called the Registry of Tools. Some of you may have heard of this because you have proposed your tools to be included on the platform, and I hope the rest of you will hear about it in the next month or two once it's launched. And this is essentially a registry that is going to be built into the second version of Red Compass, which is soon to be released. And this essentially lists all of the tools, their CALM level, so their operational readiness, and links those tools to specific actions that a country must undertake within the Red Compass framework to implement their national forest monitoring systems. So it pitches the tools in that framework that countries need to use them for. So obviously, the development of these systems is very complicated. It isn't just technical efforts, it's of course institutional arrangements and all of the other, I guess, political things that need to go on for these systems to become operational in countries. But going from the MGD to the Red Compass to the Registry of Tools, it contextualizes these very technical products within an operational framework. And the next step in this process, the Registry of Tools essentially is some high-level information, summarizes the tool, where the tool can be accessed, its operational readiness, and of course, the specific actions within Red Compass. But the next step in the process is Openmrv, which we're actually going to be launching next week. And I'll put a link to the launch plan in the chat if people are interested in joining us. And this is essentially a platform which GFOI's leading partner, the World Bank, has developed as a contribution to GFOI. And this provides, I guess, detailed, user-friendly instructional material for the implementation of specific tools. So not only does it provide, I guess, a whole new set of manuals and training resources, but it organizes them in a logical and structured way that says this is a product that can be used for producing, land use change estimates or, activity data, and these are the specific products that we have available for countries to use. It also includes some standard operating procedures that countries are using. So with this framework here, we are providing, I guess, a sort of end-to-end package of support where you go from the original conceptual decisions, the original system design framework that the MDD presents right through to the implementation of these specific tools. So in the context of this workshop, it would be really nice to get some of these tools included in the Registry of Tools, and also in between the Registry of Tools and Openmrv, having them hosted on CEPL, so there is an easy access for them to be used by countries. And additionally, I guess some detailed instructional material provided and hosted on the Openmrv platform, so that countries can actually implement them once they've worked their way through all of the decisions they've had to take in designing their own national forest monitoring system. So I just wanted to put that out there to show that this is a framework that GFOI works in. We're trying to provide a bit of structure to all the work that you do and contextualize it within a framework that that countries can use for implementation. So just wanted to add that at the start, Gilberto, but I'll throw back to you now. Welcome any questions people may have though.
Right. Thank you so much, Tom, for sharing us. So I actually shared on the chat the link to I put the paper by Curtis on the same directory. Put everything. I hope Curtis doesn't mind. I'm making, sharing your paper. So Martin, please.
Yes. So thanks first of all, everyone, the GEO Secretariat, Roberto, and also the GFOI office for organizing this. This has been very interesting, a lot of rich information. So I learned a lot, and that's always where they're always open. They have a lot of new energy about developments and also on how they're dealing. I think, Roberto, I very much agree with your way forward. I think the plan looks good. Full support also from the GFOI R&D component on that. So you can count on us to support that process. That's the usual things also that the R&D component does, because the framework that Tom just presented is fed by several things. So several things make that work, which is of course the needs by countries and the evolving needs by countries, but also the developments on the technical side and on the data side and how they can feed into that framework. And I think that's part of what we're doing here, is really how can we use this process to feed into the framework that Tom was presenting. I think we saw a lot of very good technical presentations. I also, as a reviewer, I feel quite comfortable to make some calm ratings for some of them. One thing though that I noticed, the presentations are, let's say, being very technical. I think they probably allow a pretty good assessment all the way up to COM level 6, which is kind of this last stage of the pre-operational. But the presentations, just because they were technical, there was not a lot of information about the COM level 7 and up, which is more than the operational uptake in countries and with countries and so on. So there was not a lot of information on that. So my encouragement for the maybe synthesizing from the self-assessment, or maybe even asking the teams to provide a bit more information on that. I've seen a couple things where that was happening, but that's, having done some COM assessments myself, that's often the most hardest to judge at the end if I really want to go beyond COM level 6. So my encouragement is that you also have to help us as reviewers a little bit in that side, and maybe that information can come from the providers or can come from, I don't know, the self-assessment summary or something like that. But besides that, very happy about the workshop, very happy what was presented, and very happy to move forward together.
Excellent, Martin. Please, floor is open, and also the Q&A. So don't be shy. Put your questions. Any thoughts? Alfonso. For the near real time, these are great tools. For the GI, we need to link them to emission factors. Also, the land use transitions are important for the emissions factors. How can this be supported? A very good question. Do we have any of our panel's experts or panelists? Martin, yes, please, take it.
It could be me again, but maybe others can wave in as well, because I think that's a very important question. I mean, in a lot of the talks, what we have seen is that one big value of using this Earth observation data, and the tools are there, that you can get information relatively rapidly. And that can be all the way from alerting, where you just want to know if something is ongoing. The DTR system in Brazil is a long-term example of that, and that's really more for enforcement, signaling things and stuff like that. Often the quality of these alerts is not as good because their purpose is alerting to really do good area estimation and feed them into greenhouse gas inventory. Having said that, though, we should try to use the opportunity of these data to really increase or help countries to increase the frequency of reporting. We do see greenhouse gas inventories, national communications, biannual update reports. The updates are relatively slow. It takes years until there's an updated greenhouse gas inventory, which is very impractical for many of the supportive mitigation actions and stuff like that. So that timing issue, and maybe it's not near time alerting, but moving towards annual or even sub-annual or kind of emissions reporting is something that I think is feasible with support of this kind of data, and that's clearly a direction we should be using, and we should not, and really it's these tools that help us to get there.
Fantastic. Any other points here? Any other takers? I saw a hand. Did I miss anyone? Oh, Curtis, please, and Maria Jose.
You know, there has to, somehow in this process, there has to be a balance between the reporting requirements and the reporting time periods. If you're expecting characterization of the uncertainty in the reporting and you want to go to sub-annual time periods, it really gets hard because the areas that are involved, just the physical areas of change become so small that having a reasonable margin of error in your estimates for that gets harder and harder. And so I don't know, obviously it would be nice to report more frequently and it would be nice to report more recently, but that may require a little bit of adjustment to the rules of the game, if you want to think of it that way, in order to get to the point where we can reliably report, or maybe there's different levels of reporting, right? You can report more effectively over longer time intervals and not quite so recently. It's just a thought. It gets very hard once you try to go to reporting monthly or reporting every 3 months or something like that, to get through the whole process of characterizing the uncertainty in the area estimates and having them have margins of error that make for credible reporting.
Yes, please. Thank you, Curtis. Maria Jose?
Yeah, I think, I mean, I'm quite pleased to see this wonderful set of tools that are emerging. And I think now we have to think on what will be the use for those. And reporting, I mean, what has been triggering this amazing, knowledge is the need to report under the UNFCCC. I mean, governments will report, I don't think they will report, monthly or anything like that. And the Paris Agreement is biannually now, and the greenhouse gas inventories are annually. And this is one function of what the information we can collect. But there are tools that are being exposed here that are very useful in other contexts, like, for example, understanding how the disturbances are evolving or not. And you don't need to be producing necessarily very accurate estimates for certain functionality of these tools. I guess what the manager or what the policymaker, and I won't say the policymaker, but the technical guys that are behind data that the policymakers need to know is how they can build a constellation these tools that will serve the different demands they have, which is not only reporting greenhouse gas inventories, which are not going to be less than annual ever. Forget about that. This is not going to happen. But how I can use this information properly for the decisions I need to make at the national level and the local level and so on, and how I can have a constellation of things that I can construct and puzzle myself at the different levels, which still produce a coherent picture, but are of use for myself. I think this is the main question we are reaching. And I don't think it's about comparing tools or saying that those are better than others. I think each of one of them, they have their use and their role, and they should not be competing. I think that's a mistake. We should not make tools competing. I don't think we should make a global model competing with an algorithm for time series consistency. No. And we should not force an algorithm for time series consistency to start attributing carbon. No, they have a different use. The point is how the user can put them in the best way for serving what they really want to do. And this is what has been coming to my mind during all these interventions. I don't think the problem is the quality. I don't think the problem is that we don't have tools. I think now is how we puzzle them in the most useful way for all the potential users. And we don't lose the perspective of the inventory compiler or the manager, which goes to the inventory compiler for data, for example.
Excellent, Maria. Couldn't agree more. And Frédéric, oui, s'il vous plaît.
Hello.
Frédéric Achard aussi. So Frédéric, you first and Achard later. So sorry.
Okay, thank you. Thank you so much for those presentations, the quality of the change and so on. Just a few remarks in the continuity of those from Maria. I think the works and tools presented are impressive, rich, very relevant supported by leading actors and communities. That is very important. Each of them cover part of the necessary needs for forest monitoring and analysis, which responds to the different challenge of knowledge measures at different scales to support public decision making. I think it's very important. It's not a way of competition, but more of researching the complementarity, synergy, and interoperability from those tools and knowledge. Information sharing, detailed knowledge, and specific condition of use are essential to choose and promote us. And I think it's maybe one of the big work of different initiative like gfoi. Some of these tools are made by specialists for specialists, and I think we have to think about how to better to have interface in the sense of using by not specialist or expert in remote sensing and so on. But I know that there is Google Earth Engine are very good in that sense, but maybe we have to think about it. The system is complex, all the objects are complex, and I think we have to imagine methodologies that can be that combine all the things. I would like to insist to the condition to better use all that kind of important tools. I think we have to create a framework of confidence around the data, the tools, and the services. This is very important, which means that we have to support the sharing expertise, and capacity building is very important. The product tools to generate the information on accuracy related to the data methods, and also condition of use, and to ensure that the process has traceability and reproducibility. We can integrate that contribution to the fair and open science and data sharing that different European countries or at international level, there is a priority of that, and we can use that kind of principle better diffuse the results. And not to and have in mind the difficulties to have a very big platform for big data treatments that's not easy to share at international level. Just few for discussion.
Merci, Frédéric. L'autre Frédéric, Monsieur Achard. Oui, yes, s'il vous plaît.
Too many Frédéric today. Thanks, Gilberto. Yeah, thanks for just from my side. Thank you for these presentations, which are what I realized that there is, as mentioned by Maria, by many others, that there is a range of scope of the different tools which were presented. It's clearly not the point to compare them or to make a rating between them. If we and I understand fully that some of them can be used differently by different users in the tropical countries. If they want either to start from satellite image or they prefer to have a full-fledged system, would give them already an answer in terms of estimates of emissions. So this full range of options, and I think it's useful that a platform like CEPAL or your gfoi MRV open platform that will be also launched can allow to give information where these tools are available, and possibly through CEPAL, if part of them or all of them can be integrated and made available as different options. Of course, that implies that the more options you provide in the platform, more complex it becomes for a user to understand. But if it's well described, it can make the job. So very positive about this, the fact that these tools can be made available, and even if they are very different scope, from more reduced to more larger scopes. For maybe if we are, as you are part of the member of experts, to be what will be easier for myself. I understand that the main output that you expect from the experts are this rating in the CALM, and I fully agree with Martin that the challenge is to say between CALM 6 and CALM 7 if that should be used as the fact that if it's operational, demonstrated that that has been used by already a number of users, that probably an incentive to include it in CEPAL more than if it's still in the research and development domain. But I think it will be easier for the experts if we get, I know that you have asked the software developers to make their self-assessment of their own self-assessment. I think it will be much easier for us to get this self-assessment and just to review that, to say we agree or we don't agree. I know that the self-assessment are including a number of background information that will be difficult for an expert to, or will take time for an expert to find by itself if it starts from zero. So my suggestion would be that if you expect us to give you some technical feedback, it would be to start from the self-assessment by the expert themselves and to give you the comments on the review on these self-assessments. I'm hoping that from that you can help you to define to take a decision of what should be included in CEPAL or not. Considering that from my side, I would consider that as many as possible tools should be that have shown already an interest by some users in the countries should be included in the open platform like CEPAL or the future gfoi MRV platform. That's all from my side. Thank you.
Okay, before I go to Sylvia, let me just thank you very much, Frederic, for making this point. We have received this CALM self-assessments from all the tools. The only one we had not received yet is Curtis and Paulo CCDC. So we would please ask Curtis and Paulo to complete the CALM assessments so we can send the individual CALM assessments to the expert group as Frederic Achat has asked for, which I think is a good point. So we'll, as soon as we get the one from CCDC, we'll send to everyone. And you're right, that helps you. Thank you very much for making this point. Sylvia, please.
I sent it a few minutes ago. So.
Oh, so thank you very much. So we've got everything. So the experts will get it. Sylvia, please.
Okay, thank you first, Gilberto, for inviting me here as a reviewer. I come from the capacity building perspective, and I'm very pleased to see all these new methods coming along. And also I'm very impressed with the progress that CIPAL have done to include all of these. I really appreciate the comment that Eric made yesterday about how it's highly reliable, and if it's CIPAL or the funding from CIPAL anytime goes away, the code is still there and users have access to that. That's specifically important for countries in terms of having a way to replicate their processes. I want to comment on Maria's about these are not competing tools, and also on the time that the countries have to report, either 1 year or 2 years, which when we face new methods and tools, and again, I'm coming from the capacity building perspective, it is still a short time. It's still a short time to test and to implement. So even though these are not made to be competing tools, at some extent, when there is testing going on, there is some level of competition inside the country on what am I going to use, how, and it's all related also to accuracy, right? What's going to give me the best accuracy, because I want to have the best results to access payments. So most of you, the developers, know that putting a tool in CIPAL with training materials, it's great. It provides the access to the methodology, but it still requires big time holding hands, right, from the developer. And Curtis, for example, know that very well. We want to implement a tool coded, which is looking at degradation in countries that is, it have GUIs and Google Ranges. It's easy to implement, but it requires a big amount of holding hands from the developer to sit with the countries to explain them how do you use the tool, and to get them to a point that where they can use them by themselves. So I think that that's one of the challenges that we face when we're trying to develop capacity. The programs that are going to be developing this capacity or bringing those tools to countries need to have the necessary number of people to train, right? So this is going to be one of the challenges as more tools become available, because some of the tools or these methodologies are really sexy for countries and they really want to use it. But that's a challenge in the level of I mean, there's training materials, but develop the level of continuity that you have to have with these countries. And my last comment is about Eric's comments again in the last presentations. He was talking about how we can combine, we can put in CIPAL a button that can combine the mosaic into others, and it makes it really easy. So I think I am conflicted about that concept a little bit, because that's also a problem if a platform is not there anymore to do the work for you, and then you have to deal with codes, and then the countries have to deal to a higher level of technical capacity to be able to do that by themselves. I understand that when we deal with reporting, we have a grade of capacity building in countries, of technical capacity in countries. So there are countries that can do everything by themselves, and there are countries that cannot do much, right? So yeah, those are my comments. Thank you.
Thank you, Sylvia. Very, very important comments. Yes, the floor is still open. Our attendees, do you want any questions or any responses to Sylvia's point?
There's a hand raised, Gilberto, from one attendee. Do you see that? Hitendra Padalia.
Can you join in? I don't see it, but I believe you.
I can allow the person to speak. That's okay.
Please do, of course.
Okay.
Are you listening me? Yes.
Yes.
So yeah, I also agree with the point which has been made by Salvia regarding the training. Some of the selected researchers, those who are already working in these areas, for some of these countries, like I come from India. So we also are have started working on these lines, these scripts which are being provided. But still, since these things are not being developed in our national forest monitoring systems, so we have to, a group of people like us, we have to develop these capacities so that at some point of time we will be able to demonstrate these tools to our nodal, like we have Forest Survey of India, so that we will be able to convince them that yes, these are the things which are happening around the world and they need to adopt these modern tools. Yeah.
Thank you. Very good. Dear attendees, any other hands raised? Anyone wants to? Hugh Giver, yes, please, Hugh. Could you help Hugh to talk, Sarah? Okay, Hugh, please. Hello?
You can speak now.
Me now? Can you hear me? Yes. Okay, thank you very much, Sarah. Thank you, everybody. Thank you for the fantastic presentations. I really love the CPAL concept with, and thank you, Eric and Remy. What we need to know is how long will CPAL be institutionally supported? And I know that CPAL has asked the European Commission to fund a longer period, but I think it's very important because actually what we're doing is we're all focusing on CPAL and using the very nice tools. Sometimes a little cryptic. Sometimes I need a bit of help to understand what's happening. But what's the long-term prognosis, Eric? If I may ask Eric, maybe, or Remy, who's there, or Aurélie, what's the long-term prognosis? Thank you very much.
Should I answer?
Yes, please.
Oh, okay. Well, I can answer, and then Julian Fox is also here, and he's the team leader of our team. In my opinion, the long-term prognosis is very good. We plan on being around for quite some time, and just to be brief, I mean, like what I said, I mean, I think we'll be in our current form for quite some time. We are looking for, obviously, the be all end all. The final goal is to somehow get like permanent, like some amount of permanent longevity within the institution, or within an institution, like permanently under GEO, permanently under GFOI, something like that. And that's what, of course, we're going to be working for long term. The options for using the idea of CPAL will always be there, right? Like the way the engineering behind the system, the way it works, the way it combines the capabilities of the cloud computing, and the way it combines things like Earth Engine with Python, with R, with all that kind of stuff. I mean, that idea that can be easily repeated and rebuilt. Likewise, CPAL can be transferred from, like, we have it in where it is now, but it doesn't have to stay there. I mean, like, we can move it from one place to another. It can be copied and pasted by other people to other places. So we're trying to make it as alive as possible, so that, trying to cover all of our bases, so that it for sure stays alive and functional. And Julian can probably speak better about that than I can. But
no, thanks, Eric. I think you said it really nicely, but it's a common question, Hugh. And I mean, from our side as the CPAL project, we've been institutionalizing ourselves as much as possible into FAO's geospatial infrastructure. We're integrated with our hand-in-hand. And actually within FAO, the open forest set of tools have been around for 10 years. and it really feels like they're only getting stronger. So I think we have a really positive outlook. We have a lot of people doing what they need to do with the tools, both those national questions and for reporting. So I think the prognosis is extremely good, and it's all open source, so it's definitely not going to disappear. I imagine over the next decade, in a decade, we'll still be running really strong with open forests, and CEPAL will be a key part of that provision. Thanks.
Thanks, Julian. Thanks, Eric. Curtis, please.
I'm curious, is there some relation with the Geo Microsoft Planetary Computing Initiative?
Well, let me try to answer this. Well, the Geo Microsoft Planetary Computing Initiative is okay. The whole idea, let's go back a little bit. The whole idea is the following. As you may imagine, the starting point and the motivation to start GEO in 2003 was to build what was then called the Global Earth Observation System of Systems. Now, let me make a blow. I've been enough on this game since the very beginning to make the following assessment. CEPAL is the first installment of a system, one system that belongs to GEOS. It's the first, in the sense that it allows countries to use Earth observation technologies. Now, one of the challenges we identified in GEO, and I identified when I came to the Secretariat, was that of understanding, simply understanding what the new technologies bring. It's not obvious at first sight. What is the cloud computing? What can you do with the cloud computing? What can you do? I mean, a lot of people use Google Earth Engine, but it's Google Earth Engine is not everything. So what we did was to offer to the community and globally opportunities to use cloud computing platforms to do geo-related work. And we launched a call with Google, we launched a call with Amazon, now we're launching with Microsoft. And Microsoft is going one better because Microsoft is offering cash. So Microsoft is saying, okay, if you want to test the planetary computing, I even give you some support, financial support, for example, for a PhD student, postdoc, or a programmer to put it there. What is the long-term plan? I mean, this is like crystal ball, but my crystal ball tells me the following. In the long term, like Julian, 10 years, we're going to have a mix of public and private services, and even have like a public service like CEPAL that uses a public cloud, a private cloud like Amazon or Google, but provides service to the community. And we're going to have people who are going to use what's available in Microsoft, for example. The only caveat for GEO was the following. Anything that's associated with the GEO, either Amazon, Google, Microsoft, is open source. Which means that if someone gets a grant from Microsoft to develop a tool on the platform, this script, Python, R, whatever, should be open source and then shared with everyone, so as to not give anyone an advantage that we would not be able to share with the community. So the whole idea, Curtis, is that there is a world out there of people who need to understand the new technologies. And the Microsoft call is one way to do it. I hope it answers your questions or someone else that has. Okay, right. There's one more panelist with raised hand. No, it was Curtis. Any attendees?
I think so we can start to wrap up with some agreed actions. I think we are all happy with the proposed process.
Could you put the slide back again, Sarah, so that we can remember what we want to do?
Yeah. Rick, can you help?
Okay, so to the expert group will receive in the next days the CALM self-assessment provided by the tools. Hopefully you'll be able to respond by the end of next week. We're not going to make, it's not a judgment, so it's a contribution. Remember that. The one is judging and the one is contributing. We hope that hopefully as early as you can, the tools can respond to GFOI and Geo saying, I'm prepared to go the next step. And I'm prepared to do this. And you have to state what you say you can. And please state if you need resource. We cannot promise resources. We're not really, but we can say, okay, we understand what the game is. Again, I think it's a self-reinforcing game, to go on Curtis' question. The stronger CEPAL becomes with the tools, the stronger we can make a case for supporting those tools. I think it's a positive circle. Now, the final point we have to agree today is a timeline. We had originally argued that 6 months would be a reasonable amount of time to get, if not the final, at least a new checkpoint. We're not going to have perhaps a one-day workshop. By that time, most of it will be in CEPAL. We have to repeat demonstrations, but we, of course, would like all of you to be there. And it's going to be just a status report of what has been achieved. And of course, we count on the support of the GFOI R&D component, following the procedures and that has been laid out and presented by Tom. So we're going to follow the procedures which have been very, very nicely established. So our proposal is to stick to the 6 months. I think it's a reasonable period to, get everyone, not enough to do everything, but enough to do a contre-rendu, as the French say. So if no one has, let's say, any, objections, no cries, I think anyone would like to say, no, I don't like this. If not, we'll stick to that. I don't hear any cries at the moment, so that's good. With that, I think we could take the last minutes here to do a wrap-up of the workshop. And I think I would like to invite, first of all, a representative from FAO. Maybe Julian could perhaps have your words, and then please Tom, and then myself. But of course, if anyone wants to have these famous last words, don't be shy. I mean, this is a democratic group. So Julian, please.
Thanks so much, Gilberto. I think everything has been said. It's been a really remarkable 2 days. I mean, CEPAL is a digital public good, and it's there for the community to use, as I said right at the start. And yeah, I think it's a great pathway for the key people that need to make better decisions, that need to report, to have access to all your amazing work. So really huge support from FAO and the CEPAL team. But really, I'd like to pass quickly to Eric, because he's the man behind CEPAL, for some closing words. Eric, please.
Oh man. Well, oh no, I did, just thanks Julian, thanks Geo, thanks GFOI, thanks to everybody for spending the last part of the last 2 days as part of this workshop, and thanks to everybody who's contributed code, who we've all had a chance to work together, and hopefully all for the better. And it's just been, like I said, also at the start, it's been kind of an overwhelming opportunity for us, for me, for the team, the developer team of CEPAL. But we're thrilled to be at this stage. And I've been frantically typing things in the chat to try and explain a little bit more about what we are and what we're trying to do. And we just want to be, we want to be the vessel there that allows all these things to be run, allows them to be run easily next to each other, combined in whatever way that makes it easier for people to find solutions and for good decisions to be made in situ, where those decisions have real land management implications. And this was CEPAL was our attempt at providing that that platform to do that. It's, yeah, like I said, it's completely open and free, and we're open to any and all suggestions, any and all assistance, any and all criticisms as well. But this has been a great opportunity for us to be here for these last 2 days, and I couldn't be happier about it. So thanks again to everybody, and yeah, I'm looking forward to see where this goes.
Thank you. And perhaps before I go to Tom, I'd like to hand over to the lady that made this all possible, whose provocation has been essential for this to happen, is the Vice President of IPCC, Thelma Crook, who is with us. And she's the one responsible. Don't blame me, blame her.
Hi, Gilberto. Hi, everyone. Oh, Gilberto, yeah, I was just, remembering the discussions we had at COP25. That was in the corner of a discussion that was going on elsewhere. And we started the discussion of this potential cooperation partnership with the TFI. So I was, unfortunately, I could not join yesterday, but I was thrilled to see so many advances in the way forward for the future. So this is absolutely fantastic. So I just would like to thank all those that have, been the presentations today. I'll catch up with those from yesterday because they have been recorded. And I see, Gilberto, that all this has numerous benefits. When I think about the IPCC and the TFI, because we don't do research, but we rely on all the innovations, all the new technologies to inform countries that these things are available so that they can provide better inventories. And now I think when I was listening to the discussions and the intervention from Maria, I don't see this, all the benefits of this only for the UNFCCC. We cannot forget that we are now in COP26, going into the discussion of Article 6, which is carbon markets, and all the information is becoming increasingly more relevant to give substance, to give integrity to the data that are provided by countries. So I see that all efforts in terms of advancing in understanding, in particular, the changes in land use, the historical consistent time series, disturbances that have been mentioned, and the challenges related to those. All these, I think that bring awareness of what is still ahead of us in terms of overcoming these challenges and improving. And all this collaboration with so many institutions, Gilberto, I think it's key to really help us advance. So as it has been said, there is no good, no better. There is partnership. There is trying to solve the issues together. And I really see that you have this leadership with other institutions. GFOI has been also instrumental. CEPAL is really opening up a huge opportunity for countries to rely on their support also to improve submissions to funding. This week I was doing an assessment for regional, it was South American regional collaboration for the Green Climate Fund. And I was looking at the proposal and they asked some help. And one of the questions is, do we have enough remote sensing information that would allow us to trust, that we are putting the money where we should do and have, tools to to monitor the changes and so on. So I assured them that, yeah, no problem. I think we are improving and giving certainty to the tools increasingly in FAST. So I would like to thank you, to thank Sarah, who was also really important to have us reaching here at the end of these 2 days webinars. And I'm really, thrilled by all the new innovations that are coming up and the efforts that everybody's making. So thank you again. Thanks everybody for the huge effort, and please keep on going. Thanks, Gilberto.
Thank you very much, Thelma. We're very honored with your presence to the workshop with the representative from IPCC at high level. So this is very important for us. Tom, please.
Thank you.
Yes, fantastic from my side as well. Thank you, Thelma. It's been great to have you and your colleagues involved. Thanks, Gilberto. I think you've done a really nice job of summarising this workshop and the next steps. I think the pathway out of the workshop that you proposed is really clear. I think those time frames are sensible, and the GFI office stands ready to continue to facilitate this process. And just going back to this point that we raised in the discussion about how can we choose the tools they need. I mean, that is the GFI framework. That is the diagram that I presented. So not only getting these things operational in the CEPAL platform, but also getting them into the GFI Registry of Tools, which of course connects them to specific actions that countries need to undertake in monitoring their forests, which again connects them to them being able to meet specific, I guess, reporting requirements from decisions taken by the UNFCCC. So it contextualizes these individual tools into broader and operational national forest monitoring systems that can be used for, UNFCCC reporting requirements and other forums. So getting them into the hands of countries and allowing countries to, I guess, make their own decisions on which tools they want to use. That is precisely the GFI framework. So getting them into the Registry of Tools, accompanying that with user-friendly instructional materials for how they're implemented on the Openmrv platform being launched next week. And then the GFY capacity building component and capacity building partners are then responsible for, I guess, taking all this work and disseminating it to countries. So we are very grateful for this workshop. It's been a really fantastic collaboration. It has been amazing to see all of the capacity that is out there within the community. It is GFY's job to help organise that into a way that countries can use this, and we look forward to continuing to do that with all of you. This has been a great example of how GFY is supposed to work as a geo flagship. And I just want to say a particular thanks to Gilberto. You initially, I think this initially came from one of your ideas in response to the MGD3 last year. It's great to see it come through to fruition. And certainly last but not least, Sarah Venturini as well, who really has been the driving force behind this, keeping us all on track right through to the very end, making sure that we have a logical next set of steps. So thank you, Sarah, as always. It's a pleasure to work with you both. Thanks to Rick as well for pressing the buttons behind the scenes, and Laron as well. So thank you, everybody. Look forward to taking this forward, and please do get in touch if you have any more questions about the GFY framework and how we can help you to get your tools into countries' hands. Thanks, and look forward to talking again soon.
Right, thank you so much. And a parting thought for all of you. I mean, this has been amazing from my perspective as a long timer, having this cooperation of so many great institutions, so many great people. I'd just like to ask one question for you to take home. Would this workshop, would this aim be possible 5 years ago? I don't think so. So we're just, I'm telling you, we're just in the threshold of much better things to come. We're just in the cusp. I mean, that's starting the curve. We labored for so many years to make Earth observation available. Now, we've never been in this place before. And this is a fantastic realization for all of us, the opportunities we're going to have. So with enormous thanks to Tom and Sarah, I'd like to thank all of you. See you back in 6 months. Bye-bye. Auf Wiedersehen. Ciao. Tschüss. Bye.
Thank you.
Thanks, Gilberto. Thanks, everybody.
Bye.
Bye-bye, everybody.
Bye all.
Bye.
Bye.